depends on C values, that's why it's not an unique solution. We cannot find the unique solution. But when another example we are showing that this example I am showing the y equal to 3 e to the power y equal to 3 e to the power 2x plus e to the minus 2x minus 3x in this differential equation y double dash minus 4y equal to 12x, and these boundary conditions are also given. This is a unique solution. Why? Because when substitute y values in this equation, we have to see it is satisfied this uniqueness of this theorem, where the all a0x, a1x and a2x are this continuous function in this minus infinity to plus infinity in this open infinity, and where a0x equal to 1 is also not equal to 0. So therefore, by existence and uniqueness theorem, it follows that equation 2 is a unique solution of this equation and satisfied also the initial boundary conditions of this differential equation. Next, the some of this. What is the initial value problem? Already I have discussed the initial value problem. This is the when these types of equations are given. This is the x naught. Here also x naught. These boundary conditions are also given, and y0, y1 are the given constant. These types of equation are the initial value problem. And another, when an equation is linearly dependent and linearly independent. Because suppose we see one equation, suppose cfx plus k into gx equal to g. Suppose these types of equation we have written as a non-zero function fx and gx. And when c and k equal to 0, we make the given equation true for all x. Then we can find non-zero constant c and k, for which given equation will also be true for all x. Then we call that two functions are linearly dependent. And when c equal to 0 and k is also 0, then we call the functions are linearly independent. That is also we define in our differential equation these types of the linearly dependent and independent, how to define among these functions. After that, we are showing when are the homogeneous equation of order n used. The homogeneous equation of order n are used for solving the initial value problem for nth order equation. But another question, what method is used for solving the homogeneous equation? Essentially, for each nth order differential equation, the method used involves a set of n linearly independent functions, that is a fundamental set of solutions in order to obtain a general solution. These are the how the non-homogeneous equation of order n can be solved. The non-homogeneous equation, for solving non-homogeneous equation, first we solve the auxiliary equation. When we are using the trial solution, means y is equal to e to the power mx, and after that we have to find out the complementary functions. Complementary function, we have written y is equal to suppose c1 e to the power something plus c2. Those are the different forms will be there for this non-homogeneous differential equation. And when non-homogeneous, it will be written as a, we have to find out the particular integral. These are when it is the non-homogeneous cases, we have to find out the particular integral. Ultimate, we have to when find the general solution, we have to find out complementary function plus particular integral. We have to find out this general solution. But we are showing these are the three cases for this auxiliary equation in the non-homogeneous or homogeneous equation for solving the differential equation. We are showing in this blackboard. Suppose if the equation is y is equal to, suppose I am showing, if equation, suppose the auxiliary equation, the m values depends on the same values is the different values. Suppose m values is suppose 2 and 4. So therefore the auxiliary equation will be written as, in this differential equation, written as the c1 e to the power 2x plus c2 e to the power 4x. We have to written it. But when it will be the same root, means m values is equal to suppose 2 comma 2, the same root, we have to return the complementary function will be written as the y is equal to the c1 plus c2x into e to the power 2x. These are the forms for this complementary functions we have to define. Because when it is the real or the different root, when it is the same root, and when m values is the imaginary root, means suppose 2 plus minus 4i. Suppose this type of root will be there. So therefore, how to find this as the imaginary root? So therefore, the complementary functions also written as the a cos 4x plus b sin 4x into outside bracket we have to written as e to the power 2 into x. We have to written there are three procedures for every homogeneous, non-homogeneous, or for the solution of complementary function of this differential equation. These are the process for this differential equation to solve the complementary functions. Okay. So therefore, one minute. So therefore, what next I am showing the partial differential equation. There are partial differential equation. There are so many cases. There are so many examples for heat equation, wave equation, heat conduction equation using by partial differential equation, and also we are using, there are so many methods. Somebody are using the Laplace transform, Gat transform, but here we are defined as a separable of variable method for solving these types of partial differential equation solution. So this is equation I am showing. This is the one-dimensional heat equation. And we are showing the separation of variable method, x is equal to xt and tt, and we substitute in this original equation and we get this relation of capital X t dash and beta x double dash t, because these relations come from this heat equation, because heat equation that is del u by del t. So therefore x term will be constant, t term is variable, so that's why it will be del t dash t, and ultimately after that we have to integrate t dash t by t of t, and we get these two equation t dash t plus minus beta kt, and this equation we have to find out. And there are three cases to solve this heat equation, and depend on these values of k. We are showing when k is equal to 0, k is equal to less than 0, greater than 0, and equal to 0. Therefore, these two equations depends on these k values, and we have to ultimately get this solution using the differential equation. We have to get the solution of the heat conduction equation. These are the solution of this heat conduction equation. And another is wave equation also we have to find using the same method, and also heat conduction equation also we have to find out using the same method. Okay, thank you. Thank you, sir. Any questions?
One question I have seen in the chat box.
Okay, let's see.
Argham Mazumdar. If we measure h from the ground, then d2h by dt2 equal to minus g, where h is equal to 9.8 meter per second.
Okay. Because this one actually is a gravitational force, that is the fixed the 9.81 actually meter per second square. This is the gravitational force G is equal to, it is the measurable, this is the standard form, and this is the standard values of this equation. 9.81, the gravitational force. Listen. Hello?
Have you there? Are you listening? Argham Mazumdar.
হ্যাঁ, অর্ঘ্যমজুমদার ইয়েস লিখেছে, শুনতে পাচ্ছে।
ওকে।
আর কারো কোনো কোশ্চেন আছে সাগর?
Another any question?
Someone is asking whether he can unmute to ask question. You are supposed to write the chat box actually. Anyway, I think.
Hello. Hello. Thank you very much for your nice. Hello. Can you hear me?
হ্যাঁ, শোনা যাচ্ছে।
Yes. Thank you very much for your nice presentation. And actually, really, we ended our mathematics to real life through your presentation. But my question is that you have discussed about the Newton's law of cooling and RL circuit also. But my simple question is that when we put a cup of tea on a table, after 10 minutes it will be cool. Actually, this process only due to the differential equation.
Yes, this is process also differential equation. I am showing in this table, right? In this table, when it will be time should be increasing. You see in my table?
Yes.
That is actually mathematical expression, capital T of T equal to, actually the equation is this term. Actually the equation of this, the cooling this term, okay. I am showing this formula. This is visible, capital T of small t equal to Tm plus C2 e to the power alpha t. This is actually the formula for this Newton's law of cooling. Right? And you see in this table, when time will be increasing, the temperature, it is the temperature table. Temperature should be decreasing.
Yes.
Right? It will be always proportional, but when time should be increasing, it will be automatically cool. Right? Any hot item, when you put in this table, after 5 minutes, it will be cool and cool. Right?
Yes.
So you can see using this formula also you can apply. That's why I am saying in our real life or in our daily life, the differential equation applications are, lots of applications are there in our daily life.
Yes.
Mathematics. When you are going to this market, means you cover some distance. You can calculate this distance according to how many distance you covered as kilometer or meter, you can calculate also. Right, and filling task question also you can see in our daily life or our real life.
Okay, okay, okay. Thank you. Thank you, organizer, to such a type of real life mathematics presentation. So thank you very much.
Any questions
Sir,
from?
can you hear me, sir?
Yes, yes.
Yes, 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 yes.
Sir, your lecture was amazing. Sir, I have just a small question.
Yes, yes, yes.
This question actually came to my mind a long time ago, but I did not get anyone to ask, so I thought I'll ask you.
Okay, no problem.
So actually, the thing is that when we calculate the velocity, suppose
Yes,
you calculate the dBdt. So
yes, yes.
in the first line you wrote dBdt minus g because we were calculating from the ground. From ground we
Yes.
were looking upwards. So is there any hard and fast rule that when we are going from ground to upwards, we take minus sign? When we come from up to down, we take plus sign. Is there any hard and fast rule of these signs, or it is just a convention?
Mm, this is now because it is a falling object, right? It will be coming down always, right? It is the falling means it will be comes. You are saying when it will be upstairs, right? When when you see, suppose any ball, okay, you any ball thrown is this outside. Sometimes the ball is going up. After that, again he falling down, right?
Right.
So, so depends on this the gravitational force. Why the ball is coming down? Because this is the gravitational force or the I'm saying this figure at a 9.81 meters per second square. This is the standard calculation. So this calculation, how to come this standard calculation? Because this is the suppose the orbit, and when you measure the radius of the orbit from the surface, the earth's surface, it will calculate the 9.8 meter per second square. The speed of ball or speed of measure or anything, this will be calculated. It is the standard, right? So that's why it always it will be the coming down. That's why this sign will be the negative. The g is equal to minus 9.81 or anything. Because when it will be going up, so therefore I think there will be no air or any medium will be there. So depends on this medium also. So the air medium it will be always 9.81. I think so.
Thank you, sir.
Any questions
Excuse
from
me,
our
sir. Excuse me.
Yes, yes, yes.
I am Prashanjit and I just before 5 months. Excuse me.
Yes, yes, yes.
You
I'm
are
listening you.
accused.
I am Prashanjit and I am research on mathematical epidemiology that before 5 months ago, and I just want to ask that if the you tell me about the different linear differential equation where is the independent variable and its differential coefficient is linear. What tell me about that? What means that? Yeah, I want to ask you about that. Please tell me about that, sir.
No,
Independent
because
variable.
no. Uh, I know because epidemic these types of model are also very nice model mathematically. Because when I calculate the computational fluid dynamics model also, that is the something is the different, but more or less the model more or less same type of this model. So actually the linear, because we are seeing that these types of equation are all are non-linear differential equation, not a linear. Because non-linear where, because the dependent variable are also the multiplied with this independent variable. Because y square into d2y by dx2 plus x dy by dy whole square. These types of equations will come for our nonlinear differential equations, right?
Yes, sir.
Right. Because your question was that when we are calculating the epidemic model or computational fluid dynamics models, all models are this nonlinear differential equation.
No, I
We
just trying
convert it
to.
as a linear differential equation, right? We convert it using by perturbation technique or using by Cauchy linearization technique. We have converted, right, as a linear term. Directly, we cannot find the model converted as a linear term, right? We have to convert as a Cauchy linearization or using by perturbation technique. We have to convert as a linear term, non-linear to linear term. Then we have to calculate using by MATLAB or any software you are using for epidemic
No.
model or
I
any
just
types
want
of
to ask about the mathematical linear differential equation where you tell me about that independent variable and its differential coefficient will be linear. That means I either the t and the dy dt will be linear, not power more than one.
yes, yes,
As
yes.
you said.
Yes, yes, yes.
Is it?
The linear difference.
I just want to ask about that linearity. I cannot ask about the perturbation or any nonlinear differential equation. I
No,
just
you are
ask
saying
about the linear differential equation.
it is visible, the linear differential equation, the slide.
I just seen, but I cannot understand about the independent variable and its differential coefficient will be linear. I cannot be understand. That's
Okay,
why
okay,
I.
okay. Okay, okay, okay. You see, suppose I am saying, suppose x squared d2y by dx2 plus x dy by dx equal to 0. Clear? So this is linear or non-linear? Obviously, this is linear equation because when you converted x is equal to e to the power j, this term converted as a this is a Cauchy-Euler equation, right?
Exactly.
Exactly.
Cauchy-Euler homogeneous form.
Yes, yes, yes. So this is also linear differential equation, right? But when you see no product of dependent variable, so here it is dependent variable means which one? Y,
Y dependent
right?
variable is here Y.
If it is y square d2y by dx2 plus y dy by dx, but it is not a linear differential equation. It will be non-linear differential equation. Clear?
Thank you. I just understand. Thank you, sir,
Yes, yes.
for this conversation. And
Okay, okay. Thank you.